Today we are going to talk about direct variation. Direct variation is when the equation, the linear equation goes through zero, zero. A point, 0, 0. Okay? So that means that it says right here, it says write and graph a direct variation equation that has the given order pair as a solution. Well, if this is a direct variation, it goes through 0, 0 and negative 312. So if we were to do our slope formula, it'd be 0 minus 12, 0 minus a negative 3, or negative 12 over 3, or negative 4. And so our equation would be y equals negative 4x plus 0, or y equals negative 4x. To graph that, if it went through 0, 0, okay, up, down 4, 1, 2, 3, 4, over 1. And that is the graph of that equation. All right, to do the next one. Okay, again, the slope of this would be, well, 0 minus a negative 8 over 0 minus 24. End up with 8 over 24, negative 24, or negative 1/3. So our slope is negative 1/3, so y equals negative 1/3 x. Our y-intercept, since it is a direct variation, goes through 0, or y equals negative 1/3 x. We graph this. If it goes through 0, 0, then it's 0. And then negative 1/3 would be down 1 over 3. 1, 2, 3. We'll go down 1 again and over 3. 1, 2, 3. And there's the graph of that. So we get to this and it says the variables x and y vary directly. Write an equation that relates x and y, then find y when x equals 12. Well, your direct variation equation is y equals ax, where a is actually your slope, but we always use ax in direct variation because there is a no y-intercept. No y-intercept. Okay, so if I needed to find my slope in this case, or my a, I would just plug this into the formula. 8 equals a times 4. Divide by 4, and a would equal 2. So my direct variation would be y equals 2x. If I plugged it back into that. And if I plugged in 12 for x, y would equal 24. If I came over and did this one, and I put in negative 10 equals a times 2/3. To get rid of a 2/3, you multiply by 3/2. End up with negative 30 over 2, or negative 15. A equals negative 15. Therefore, y equals negative 15x. If I plugged in 12, I would get y equals negative 180. All right, it says tell whether the equation represents direct variation. If so, give the constant of the variation. A direct variation does not have a y-intercept. So we solve this, and if it has a y-intercept, it is not a direct variation. So if I solve this one for y, I'd get y equals 3x plus 4. Has a y-intercept, therefore not a direct variation. I solved this one for y, and I ended up with 3y equals 10x plus 7 divided by 3. Y equals 10x, 10 over 3 plus 7 thirds. Y-intercept, therefore not a direct variation. Last one here says, tell whether the data in the table show direct variation. If so, write an equation relating x and y. Well, let's just write an equation of this table. Okay, my rise in this is -1. My run is 3. So my slope is -1/3. M equals -1/3. If I wanted to write an equation to this, first I'd have to find the y-intercept. So the this form right here is our slope-intercept form. If I have my slope and a point, okay, I can find my y-intercept. All I do is I plug in a point. I'll plug in this point right here. I'll circle with a gray up here. I'm going to plug in 3, -1. Okay, and when I plug that in, I get -1 equals -1/3 times 3 plus b. End up with -1 equals -1 plus b. Add my 1 to both sides and b equals 0. Therefore, if I was to go back and rewrite this into this equation, I would get y equals -1/3 x plus 0, or y equals -1/3 x, which means there is no y-intercept. The y-intercept is 0, so this is a direct variation. Yes, direct variation. Okay, if I went over here and did this one, my rise is 2, my run is 1, therefore 2 over 1 is my slope, or just 2. If I plug in this first point right here, I would end up with 7 equals m, or 2 times 1 plus b. End up with 5 equals b. So it has a y-intercept of y equals 2x plus 5. Therefore, not a direct variation because it has a y-intercept at 5. Has to have a y-intercept of 0 or it is not a direct variation.